This lesson is about reconstituting dry powders that do not expand. When you're calculating the reconstitution of dry powders that do not expand, you need to calculate how much liquid is needed to dissolve the powdered medication. And this is so that the proper amount of drug is contained in the logical amount of solution, which is the amount that the doctor ordered. You need to calculate the appropriate dosage for the patients and label the vials correctly. Now, in these problems, you'll be given a vial with the dry medication at the bottom. You have to add liquid to the vial, which is reconstituting the liquid, and then determine the dosage needed to fill the doctor's orders. Since the powder doesn't expand, the volume has to equal the amount of the liquid that is added. You need to decide on the best amount of liquid to add to the vial to make the mixture what you want. But you have to pay attention to the size of the vial. You do not want to overfill it. The basic setup for all of these examples are going to be the same. Your order per dose times the amount of liquid that you need to add divided by the amount of powder times any conversions that you needed, and this will give you the dosage. So in example 1, a patient is to receive 200 micrograms of a particular drug. The medicine that comes in a 10 milliliter vial contains 800 micrograms of the powdered drug, so obviously more than what is needed. You have to decide how much liquid to mix with the powder in order to get the appropriate amount. What dosage needs to be based on how much you've diluted the medicine. If at all possible, we try in this class to get the dosage value to 1 milliliter. And then how to label the mixture for the next person on duty. So what do we need to consider when we're choosing the amount of liquid to add? We have to consider the size of the container. If I only have a 10 milliliter vial, I can't add 20 milliliters of liquid. And we want to try to see if we can possibly come up with numbers that cancel out with the denominators so that we get nice dosages to give the patients, something on an even value of 1 milliliter or 2 milliliter dosage. So in example 1, again, we're talking about a patient who has to receive 200 micrograms of a particular drug. And this medicine comes in a 10 milliliter vial. In this example, we have a 10 milliliter vial, so we can pick any whole number anywhere between 1 and 10 to add to the powder, but they won't all give us a nice number. We're trying again to find something that's an even amount to give. So consider the numbers already in the problem. We'll have 200 micrograms per dose, which is the dosing amount. We have X number of milliliters over 800 micrograms because that's the amount that's in the vial. So you see the 200 and the 800 cancel out 4 times. Since 4 is left in the denominator, you might want to choose either 4 milliliters or 8 milliliters, because both of these are less than 10, and both of these will give us an even number of milliliters in terms of our final dosage. So as you can see here, in the case number 1 where you add 4 milliliters, your equation would be 200 micrograms per dose times 4 milliliters for 800 micrograms, which comes out to be 1 milliliter. So your add would be 4 milliliters of water, your give would be 1 milliliter, and your label would be 200 micrograms per 1 milliliter. Now in case number 2, where you add 8 milliliters, your equation is exactly the same. 200 micrograms times 8 milliliters per 800 micrograms, which is your dosage of 2 milliliters. In this case, your add is 8 milliliters, your give is 2 milliliters, and your label is 200 micrograms per 2 milliliters. Now, one should take into mind what they're doing. If you're going to give a medicine by injection, you want to give the absolute smallest amount. So therefore, you want to use the 4 milliliter to do the reconstitution. If you're giving medication by mouth, you might want to go with the larger amount and therefore use the 8 milliliters. So our next example, we have a 5 cc vial containing 200 micrograms of the drug, but the order is only for 0.05 grams. So we want to cancel out the 0.05 and the 200 first, and then cancel the 1,000 into 4,000. Since there's a 4 left in the denominator, we should choose to add 4 milliliters, which is fine because we have a 5 cc vial. And of course, 5 cc's is the same as 5 milliliters. So our setup is our dosage, which is 0.05 grams per dose, times X number of milliliters divided by 200 milligrams, which is the amount of the solid in the vial, times our conversion amount, which is 100 milligrams per gram, and that's our dosage. So we can rewrite this as 1 gram per dose is equal to X milliliters per 4,000 milligrams. Again, we've canceled out our 0.05 and our 200. And we have the same conversion, which is 1,000 milligrams per gram. We then cancel out our like elements. The grams go away, the milligrams go away, and that leaves our dosage in milliliters. So our final answer would be, in this particular case, it would be 4 milliliters of add of water. Our give would be 1 milliliter, and our label would be 0.05 grams for 1 milliliter. Our final example for this lesson is we have a 2 milliliter vial that contains 400 IUs. The order is, though, only for 100. Now again, you cannot add more liquid than the vial can hold. So for example, if you had a 2 milliliter vial, you can only add 2 milliliters of liquid. So even though you would like to add 4 milliliters, you can't because it would overflow the vial. 4 milliliters would give you a nice even number, such as 1 ml, which is what we recommended. But in this case, it's not a viable option. So your setup is the same as always. You have your dosage, which is 100 units per dose, and you have your number of mLs for 400 units, and the 400 units is what's in the bottom of the vial. You cancel your unit elements as such, and that gives you your dosage in ml. So your final equation will be 100 units divided by, or 100 divided by 1 times 2 milliliters divided by 400. That'd be 200 milliliters divided by 400, which is 0.5 mLs. So you've added 2 milliliters to your vial. Your give is 0.05 milliliters, and your label would be 100 units per 0.05 milliliters. This concludes the lesson for reconstituting dry powders that do not expand.